All right, let's go ahead and continue working on finding our first and second derivatives here. So here we have f of x is equal to the natural log of x divided by 4x. And in this case, it's much easier to go ahead and pull out a 1 over 4 as a constant. So we just are really taking the derivative of ln of x divided by x. Now we go ahead and take our first derivative here. So now we have to use the quotient rule once again. So we have 1 over x times x minus 1 times ln of x over x squared, going ahead and using our quotient rule. 1/4 stays pulled out here, and we're going to leave it out most of the whole time until we're done. And when we go ahead and simplify this x here, and the 1 over x cancels, because this is the derivative of ln of x times x, so those two things just cancel out. We're left with 1. And 1 times ln of x is just ln of x over x squared. And we're going to leave our 1/4 pulled out because we're going to go ahead, take our second derivative, and we're going to do the same thing all over again here. So then we have negative 1 over x now times x squared, and then minus 2x times 1 minus ln of x over x to the 4th. In this case, we're going ahead and using a little bit of chain rule here. Still leaving our 1/4 out to the side. We're going to go ahead and cancel one of these x squareds out with the x in the denominator. But remember, we have a negative here. We have 1x left over, so we have negative x. And then we're going to distribute the minus 2x into it, so we have negative 2x. Plus, because there's going to be a sign change right here, 2x ln of x all over our x to the 4th. Okay, I think I misspoke. I'm supposed to take quotient rule again. And then we're going to go ahead and combine like terms. So we have minus 3x plus 2x ln of x over x to the 4th. Here we can go ahead and pull out an x. Because we have a negative 3x and a 2x, we can pull an x out of those terms. We can't pull an x out of ln of x. We have to leave that one there. Right. So when we pull out an x, it cancels out with one of the x's in the denominator, and we're left with negative 3 plus 2 ln of x on the numerator. All right. We still have this 1/4 out here, so we want to go ahead, bring it back in, and our simplified fraction is negative 3 plus 2 ln of x over 4x cubed, and this is going to go ahead and be our second derivative. Now, when we go ahead and plug in x is equal to 0, it makes the denominator undefined here. But remember, it was also undefined in our original function. So we already knew that was going to happen to us. So it's undefined, so we don't need to worry about finding the derivative at 0, the second derivative at 0. The second derivative at 2, go ahead and plug it in. Now it gets really messy here. When you go ahead and plug it in, we have negative 3 plus 2 ln of 2 over 32. And you're just going to go ahead and plug this into your calculator. In this case, we rounded to the nearest thousandth, and we have 0.050. And you'll just go ahead and you could either leave it exact if it asks for it, or you could go ahead and round as indicated in the problems that you're working on. Let's go ahead and look at one more using all those same f of x values that we're plugging in. And we're going to go ahead and look at f of x is equal to 5e to the negative x squared. Okay, and now we're going to go ahead and use our product rule once again. So we have our constant 5, which we're not messing with. We have e to the negative x squared, so 5e to the negative x squared times negative 2x, all right, which is our derivative of our exponent up here. And we go ahead and put that together, negative 10x e to the negative x squared. All right. From here, we're going to go ahead and use the product rule to take our second derivative. So we have negative 10e to the negative x squared, negative 10x e to the negative x squared times negative 2x. And we get to put all of this together And these two negatives are going to make a positive. So our first part is going to stay the same, negative 10 e to the negative x squared. And then we're going to go ahead and put all this together. So negative 2 times negative 10 plus 20 x squared, because we have an x here and an x here, e to the negative x squared. From here, we're going to go ahead and plug in our x value of 0. Remember, e to the 0 is just 1, so we have negative 10 plus 20, and we end up with just a negative 10. So we're definitely at x is equal to 0. We're decelerating by 10. We'll go ahead and plug in 2 to our second derivative. This is going to make things a little more interesting. So we have negative 10 e to the negative 4, because we have x squared, so 2 squared is 4, plus 20 times 4, and e to the negative 4 again. And we end up with the value negative 10 e to the negative 4 plus 80 e to the negative 4. And again, you can go ahead and combine like terms because our e values are to the same exponent, and we end up with positive 70 e to the negative 4. And we go ahead, this is an exact value. If we want to go ahead and again round to the nearest thousandth, we end up with about 1.282. So it's a positive value. So we're still accelerating in a positive way at the value of x is equal to 2. All right, let's go ahead and look at taking not only the first and second derivative, but extending this out to the third and the fourth derivative. So if we look at a nice polynomial, f of x is equal to 5x to the fifth power minus 3x to the fourth plus 2x cubed plus 7x squared plus 4, right? But going ahead and taking the first derivative, we get 25x to the fourth minus 12x cubed plus 6x squared plus 14x. This 4 drops off. Taking the second derivative, so now we have that 25 times 4, 100, x cubed, 3 times 12 minus 36x squared, 6 times 2, 12x plus 14, this x drops off. Taking the third derivative, so 3 times 100, 300, 2 times 36, 72x, and plus 12, the 14 drops off. And then one more time, 2 times 300, 600 minus 72, the x drops off. So polynomials, I could still go and take one more derivative. If I wanted to, I could actually go for this one and take the fifth derivative. And then I would be done because I would be just left with a constant. If we look at part B here we have x minus 1 over x plus 2. All right, and here again we have to go ahead and use the quotient rule. So taking the quotient rule, the derivative of the top is just 1 times x plus 2 minus the derivative of x plus 2, which is negative 1. 1 times x minus 1. And it's going to be over the denominator squared, so x plus 2 squared. Going ahead and distributing and canceling out, our x's are actually going to cancel, leaving us with just a 3 on the top over x plus 2 quantity squared. And if we wanted to go ahead and just write it without a denominator, we could bring it up to the numerator with a negative exponent. In general, we like to leave our exponents positive, but because we're continuing to take the derivative, we're going ahead and bringing it up to the top so we can go ahead and continue taking our derivatives. If we go for the second derivative here, remember 3 is just a constant, it's going to be hanging out. And so that negative 2 comes over here to the 3, giving us our negative 6. Subtracting 1 from the exponent, we get minus 3, and our x plus 2 stays in there because this is our chain rule. And the derivative of the inside comes to 1. So remember, the chain rule sneaks in. A lot of times, always be ready for the chain rule to appear. Combining like terms, 1 times the negative 6 isn't going to change anything. And again, we're going to go ahead and leave this as a negative exponent because we still have 2 more derivatives to go. Okay, going ahead and taking the third derivative, so the negative 3 times the negative 6 is going to give us a positive 18. Subtracting 1 from the exponent, we get negative 4 times the inside here, the x plus 2, and the derivative of the inside, which is 1. And we have 18 times x plus 2 to the negative 4 power. I'm not going to go ahead and write it like this yet with a positive exponent because I still want to go ahead and take the fourth derivative of this. So again, using our chain rule here, we get negative 72 times x plus 2 to the negative 5. And here we want to go ahead and write the exponent as positive because we're done. We found the fourth derivative, and go ahead and write negative 72 x plus 2 to the fifth. Now, if you were asked to write both of these out and those were your only answers, you would go ahead and write this form out. But while you're taking the derivative and continuing to take the derivatives, leave it in this form right here with the negative exponent until you got all the derivatives that you've been asked to go ahead and create. All right. Let's go ahead and look at a natural log one. So here we have f of x is equal to the natural log of x. We're going to have the first derivative, second derivative, third derivative, fourth derivative, and oh my goodness, we're going to go ahead and do the fifth derivative also. All right. So if we go ahead and take the first derivative of ln of x, it's 1 over x. Really easy. And again, we could go ahead and write that as a negative exponent to help us out. The second derivative, we're going to go ahead and have negative 1 here, x to the negative 2. And because they were asking specifically for these, we're eventually going to write these as our positive exponents, which is negative 1 over x squared. But we're still going with this. We're going to work with this version right here. Going ahead and taking the third derivative, negative times negative is a positive 2, x to the negative 3. So our third derivative is going to be 2 over x cubed. Fourth derivative, we're going to go ahead and take these two. It's going to become minus again. So notice we're rotating signs here. And so we have negative 6x to the negative 4 power, which is negative 6x to the fourth. And I think you can predict what's going to happen to our fifth derivative. Our fifth derivative here is going to go positive on us again. And we have 24x to the negative 5, which we're going to write as a positive exponent as 24 over x to the fifth. So for this particular one, notice that we kept changing signs from positive to negative. So our first derivative was positive. Our second derivative was negative. Our third derivative was positive. Our fourth derivative was negative. And our fifth derivative was positive. So this is going to happen with ln. If we were to take the sixth derivative, we would go back to negative again. So sometimes these rotate signs back and forth. It's really important to go ahead and just keep an eye on your signs.